All right, continuing problem number 3 from the year turn on section 8.2. We're factoring by grouping this time. So I'm going to go ahead and underline, get those two grouped together. So out of the first two, I'm going to take the GCF of a y squared, leaving me with an x from the first term and a y from the second term. Now looking at the second two terms, I can see, keeping in the back of mind, these were positives, right? Those are both negatives. So I'm going to take a negative 1 out, and that's going to give me a positive x, and it's also going to give me a positive y. Now I have 2 terms, and from those 2 terms, I'm going to take the GCF. That GCF is x plus y, and that's going to leave me with a y squared minus 1. Now again, like I said before with factoring by grouping, sometimes, or factoring in general, sometimes when we get finished, we're not going to be finished at all. We're just finished with one strategy of factoring. And this problem, I'm going to put a star by it again because this one actually will factor more. We're going to learn about that strategy in another lecture. All right, 2 here, 2 here. So I'm going to take an x out of these first two, which is going to leave me with a 5x from the first term and a positive 1 from the second term. Now these are both negatives, and I had both positives here, so I am going to think about that. I'm going to take out a negative, and I see there's a y in common, so I'm going to take out a negative y, which is going to leave me with a positive 1 and a positive 5x. And that's it. Now I have 1 term here and 1 term here. Now again, I have to remember the commutative property. 1 plus 5x is the same as 5x plus 1. So I see in each of these my GCF is a binomial GCF of 5x plus 1. So I'll write that binomial GCF down. Get prepared to have a 2-term polynomial here. From the first term, I'm left with an x, minus from the second term, I'm left with a y. And there we go, that's factored. One of the things that students will make a mistake on in factoring by grouping is I often will see an answer that will look like 5x plus 1 quantity squared, and then I'll see the x minus y. Well, 5x plus 1 quantity squared, you didn't take a 5x squared plus 1 squared. Yeah, there are 2 of them, but it is a GCF. So this one is not correct, and I don't want you to make this mistake. That is wrong. And you don't want to say, oh, there are 2 of them, so I'm going to put a squared there. Because what you're doing is you're factoring a GCF. So you took that factor that was in common and you wrote it down right there. And then you said what was left over. And I was left over with an x and I was left over with a y. And so that's what your answer should look like. Right, now looking at the last one here, I'm going to look across all the way and look at that. I have a GCF potential, so I'm going to see, okay, I can take out a 3 from all of them. Nope, not a 3. 3 won't work all the way across. So it looked close, but I didn't have that. And the 9 and the 16 is the big kicker here. This one's made of 3s and this one's only made of 4s. Now the 12 and the 9 both have 3s, so it's the 16 that boots it out. So I'll just go ahead, factor by grouping here and here. So out of these first two, I'm going to take a 3y squared, which leaves me with a 4y plus 3. Now out of the second two, I can take a 4. So I'm going to take out a 4, and that's going to leave me with a 4y. And then out of the second one, 4 comes out of 12 and leaves me with a 3. And now 2 terms here and here, and so I can see that my binomial GCF, I'll write it down as 4y plus 3. And that leaves me ready for a binomial here. Out of the first term, I'm left with a 3y squared, and out of the second term, I'm left with a 4. And that will be it. Now that one we'll learn later doesn't factor anymore for sure. So those are the year turn problems. Hopefully that went well, and now we're going to be ready to jump on into doing a simplification of rational expressions, and this is from section 12.1 of Lehman's text, but it gives an application of our factoring. And so I want to start in of, hey, why would we want to use this? So that's what we'll be doing in the next lecture.